Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0139, indicates an issue with the secondary heated oxygen sensor, also known as secondary HO2S or sensor 2, in a Honda Civic model from 2022 and later. This error specifically refers to a slow response time of the sensor, which plays a crucial role in monitoring the oxygen levels in the exhaust gases. The secondary HO2S is located downstream of the catalytic converter, monitoring the efficiency of the exhaust after treatment. An issue arises when the sensor's output voltage does not change during stoichiometric feedback, a process critical for maintaining optimal air-fuel mixture in the engine, prompting the Powertrain Control Module, PCM, to store this DTC. This guide aims to provide a thorough understanding of the symptoms, possible causes, and a detailed troubleshooting process to resolve this DTC effectively. The P0139 code specifically pertains to the operation of the secondary heated oxygen sensor, or secondary HO2S sensor 2, which is an essential component of the vehicle's emissions control system. Its primary function involves monitoring the oxygen content in the exhaust gases exiting the engine, particularly after they pass through the catalytic converter. This data helps the PCM make necessary adjustments to the air-fuel mixture, aiming to optimize combustion efficiency and reduce harmful emissions. The secondary HO2S is installed downstream from the catalytic converter, where it evaluates the converter's efficiency by comparing the oxygen levels before and after the catalytic process. If it detects slow or unresponsive changes in its output voltage signal, the PCM interprets this as a fault in the sensor's operation, thus activating DTC P0139, indicating an abnormally low responsiveness. Several factors can contribute to the triggering of DTC P0139. One of the most common causes is the presence of exhaust leaks, which can interfere with the sensor's ability to accurately read oxygen levels. This alteration in exhaust flow can severely compromise the performance of the secondary HO2S, leading to incorrect voltage readings. Furthermore, a faulty secondary HO2S sensor itself may lead to slow response times due to internal wear, contamination, or damaged components. Additionally, wiring issues such as corroded connectors, fraying wires, or shorts can disrupt the signal transmission between the sensor and the PCM, further exacerbating the problem. Therefore, a comprehensive inspection to identify these potential causes is essential for effective troubleshooting. The symptoms associated with DTC P0139 can vary, but the most noticeable is usually the illumination of the check engine light on the dashboard. This warning indicates a fault that needs attention and is often accompanied by other performance issues. Drivers may also experience diminished fuel efficiency due to improper air-fuel mixture adjustments resulting from the faulty secondary HO2S readings. Additionally, increased emissions can arise as the engine may fail to operate within the optimal parameters necessary for controlling exhaust output. These symptoms underline the importance of swiftly addressing any issues related to the secondary oxygen sensor to maintain vehicle performance and compliance with emissions regulations. The first troubleshooting step for addressing DTC P0139 involves starting the engine and stabilizing the engine speed at 3,000 revolutions per minute, RPM. It is crucial to ensure that the vehicle is in either park or neutral for continuously variable transmission, CVT vehicles, or neutral for manual transmission, MT vehicles during this initial step. Maintaining the engine speed at 3,000 RPM without load simulates conditions that help the PCM assess the performance of the secondary HO2S under controlled circumstances. This duration should extend until the radiator fan activates indicating that the engine has reached the necessary operational temperature for the testing. Once the fan engages, the vehicle is prepared for the next phase of the troubleshooting process. Following the stabilization of the engine speed, the next step involves taking the vehicle for a test drive. During this test drive, it is essential to adhere to specific driving conditions to effectively gather diagnostic data. The vehicle should be driven at a steady speed between 55 to 75 miles per hour, 90 to 120 kilometers per hour, for at least 1 minute. This driving scenario ensures that the secondary HO2S operates within its intended range and provides accurate readings of exhaust gases. Additionally, it is crucial to decelerate with the throttle fully closed for a duration of 10 seconds or more, allowing the PCM to monitor changes in exhaust composition as the vehicle slows down. Observing these parameters helps evaluate the performance of the secondary HO2S accurately. After the test drive, the next troubleshooting step requires monitoring the exhaust temperature via the Honda Diagnostic System, HDS. Specifically, the technician should check the catalyst temperature, catalyst temp, to determine its value in degrees Fahrenheit or Celsius. The set benchmark for a properly functioning system requires that this temperature exceeds 842 degrees Fahrenheit, 450 degrees Celsius. If the temperature reading is not above this threshold, it indicates that the secondary HO2S may not be reaching its operational temperatures, which can signify a malfunction or inefficiency in the system. Should the readings fall below this required temperature, it necessitates repeating the previous step to confirm accurate diagnostics. Continuous monitoring of the catalyst temp is critical for validating the effectiveness of the emissions system. The final troubleshooting step is to monitor the onboard diagnostic (OBD) status, specifically for DTC P0139, using the HDS. The OBD system continuously evaluates the various parameters related to emissions control and sensor performance, allowing technicians to identify any stored fault codes. By checking for the presence of DTC P0139, the technician can ascertain whether the troubleshooting efforts have successfully resolved the issue with the secondary HO2S, or if further investigation is necessary. The monitoring of OBD status provides insights into the health of the vehicle's emissions system, ensuring compliance with environmental regulations and optimal vehicle operation. Therefore, clear documentation of the diagnostic process and results is essential for accurate repair history. After undertaking the necessary repairs to correct the issue indicated by DTC P0139, it is vital to perform a final verification to ensure the effectiveness of the repair. This verification process comprises repeating the previous diagnostic steps to confirm that the secondary HO2S is responding appropriately and that the PCM no longer stores the fault code. Conducting these follow-up tests not only validates the success of the repairs, but also ensures that the vehicle operates within its intended parameters during regular driving conditions. If the DTC reappears after verifying the repair, it may indicate the need for further diagnostic evaluation to troubleshoot any remaining issues. Consistent follow-up and validation serve as key components of effective vehicle maintenance and repair processes. To prevent the recurrence of DTC P0139, implementing a robust preventive maintenance routine is crucial. Regular inspections of the entire exhaust system should be conducted to identify any potential leaks or damages that may compromise sensor effectiveness. Keeping an eye on the condition of the secondary HO2S is equally important, as early detection of performance degradation can save significant repair costs and avoid unnecessary emissions issues. Technicians should recommend routine monitoring of the oxygen sensor's output during regular vehicle service intervals to ensure it functions optimally. Additionally, keeping the PCM updated with the latest software can enhance its diagnostic capabilities. A proactive maintenance approach significantly reduces the risk of experiencing future DTC-related issues. In conclusion, DTC P0139 signifies a malfunction related to the secondary heated oxygen sensor, specifically highlighting slow sensor response times. Proper understanding of its role within the emissions control system and careful monitoring of associated symptoms is crucial for effective diagnosis and repair. The troubleshooting process provides a structured approach to pinpointing the underlying causes, including exhaust leaks, faulty sensors, and worn wiring. By completing the recommended steps and confirming repair success, vehicle owners can ensure that their Honda Civics will continue to operate efficiently and within emission standards. Incorporating regular inspections and preventive maintenance will further enhance the longevity and performance of the emission system, ultimately contributing to responsible vehicle ownership. Please like and subscribe to the channel. See you next time.